This rule is for the magnetic force on a charged particle. Now we're going to use the right-hand rule for positive charges. And it is also possible to use a left-hand rule for negative charges because negative charges do the exact opposite of what positive charges would do. In this rule, the pointer finger becomes the direction of velocity as it had been used in the past. But what's new is we will now let the middle finger be the magnetic field direction. And then something else that's new as well is the thumb will be the direction of the magnetic force on that charged particle. Now this one's going to be a little tough to draw in 2 dimensions, so I'm going to try to represent it in 3 dimensions. For that first one, let's go ahead and draw a plane that's laying down horizontally here. The field direction is into the plane. Okay, so I'll just represent that with these red arrows. And of course they cut through the plane and just keep going. Now since this is a negatively charged particle, I'm not going to use the right-hand rule. I'll use the left-hand rule. The left-hand rule works just like the right-hand rule. As you can see, you want to hold your pointer finger at 90 degrees to the middle finger, and you want to hold your thumb at 90 degrees to the pointer finger as well. But you have to rotate your hand so that the pointer finger points in the same direction that the particle is moving. Okay, so this is going to be my pointer. Now our middle finger needs to be the magnetic field. So I have to move my hand around such that my middle can point down. If I maintain the same shape as is shown in the picture above, what ends up happening is that the thumb will point out here toward me. Okay, and then there'll be some other fingers here as well, which are just curled behind the hand. All right, let's draw the directions of each of these vectors now. So our pointer is the velocity of the electron or negatively charged object here. Our middle finger is the magnetic field direction, which points straight down. And then our thumb will give us the direction of the magnetic force on that particle. You can call it FB or FM. Either one is common. So now we can see that as this particle moves across the plane, it's going to be pushed. It's going to be pushed out toward this direction, which seems kind of strange and counterintuitive because the magnetic force here is in a different direction than the velocity and the magnetic field. So we can go ahead and give an answer to this in terms of I, J, and K, we see that the velocity is in the positive I direction. Magnetic field is into the page. And when that happens, there will be a magnetic force exerted on the particle in the downward direction. And so the direction of that would be negative J hat is the direction of the magnetic force. All right. What if we have a positive charge? Well, then we should use the right-hand rule. We had used left-hand rule for a negative charge. Now let's go over to the side here and let's draw what's happening in this situation. Our magnetic field is into the plane once again. And it cuts through the plane. We have a positively charged particle in the plane whose velocity is this direction. So there's definitely going to be a magnetic force because the velocity and the magnetic field are 90 degrees to each other. Now what we want to do is we want to use this right-hand rule here in the upper left. We'll align our pointer finger in the direction of V, though. But we have to rotate our hand so that our middle finger here is able to point down. When we do that, though, our thumb ends up pointing to the left. So this is the pointer, the middle, and the thumb of the right hand. Pointer points in the direction of the velocity. The middle finger points in the direction of the magnetic field. And the thumb gives us the result, the magnetic force that positive particle will feel. So when we go to the 3D diagram to draw the direction of the force, we want it to be a new direction which is different from the other two. So as this particle moves across that plane, it's going to feel pushed to the left due to its motion in the magnetic field. And that's what we can draw in our 2D diagram as well. This would be a negative I hat force. Try the remaining four for yourself, and then I'll give my answers in a minute. When it comes to this third situation, interestingly, the direction of the force will be out of the page. and that is the k hat direction. For the remaining three, the answers would be j hat. There will be no force in this middle one. And negative j hat.